We're on page 7 of our Chapter 16 notes packet, the binomial theorem. From earlier work in algebra, you're familiar with the term binomial, an expression consisting of two terms, such as x plus y or x squared minus 5. These are binomials because they all show two terms being combined by addition or subtraction. A binomial expansion is taking the two terms expression and raising it to successive powers as shown. If we take a plus b raised to the 0 power, well, anything to the 0 power is 1. A plus b raised to the first is simply a plus b. A plus b squared, foiling that, would result in a squared plus 2ab plus b squared. A plus b raised to the third would result in a to the third plus 3a squared b plus 3ab squared plus b cubed. And then a plus b to the fourth would result in 1, 2, 3, 4, these 5 terms. And a plus b to the fifth would result in 1, 2, 3, 4, 5, 6 terms. Okay, notice that a binomial raised to the nth power has n plus 1 terms. Right? Raised to the fifth had 6 terms, raised to the fourth 5 terms, raised to the third 4 terms, and so on. Notice that a binomial raised to the nth power has n plus 1 terms. Now let's look at the coefficients of each term in the expansion above and see if we notice a pattern. Just looking at the coefficients. 1, 1 and 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, this pattern is as such. We're going to form a triangle. We'll start with 1. We'll start with a triangle in the form of 3 ones. Right? There's a triangle of 3 ones. Now, for the next line, bring down each one towards the outside, and then combine. 1 plus 1 is 2. For the next line, bring down each one towards the outside, and then add. 1 plus 2 is 3, and add. 2 plus 1 is 3. Next line, bring down each one towards the outside, add. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And notice this line here, 1, 4, 6, 4, 1, matches this line here, 1, 4, 6, 4, 1. Continue. Bring down the triangles towards the outside. Bring down the ones towards the outside and add. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And we can keep going. We can go to the next one. If I bring down the ones towards the outside, add. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. So if we were to take a binomial a plus b and raise it to the 6th power, the coefficients of each of our 7 terms would match this. Okay? So this arrangement of numbers is known as Pascal's triangle, after the French mathematician and physicist Blaise Pascal. The following formula is on a reference sheet. You may or may not choose to use it, because I choose not to use it. These coefficients here also match up with our combinations. If I have 0, choose 0, that's equivalent to 1. 1, choose 0 is equivalent to 1. So is 1, choose 1. Next, 2, choose 0 is equivalent to 1. 2 choose 1 is equivalent to 2, and 2 choose 2 is equivalent to 1. Our next line, 1, 3, 3, 1, is equivalent to 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Our next, 1, 4, 6, 4, 1 would be equivalent to 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Okay, so now we want to take and expand m plus 2 raised to the third power. Let me back up. If we have x plus y raised to the n, we have a binomial raised to the n, we can simply plug in to this formula. Notice that your exponents for x, your x exponent, right, starts high and decreases. And the exponent for y starts at 0 and increases. So instead of using this formula to expand the binomial, such as this, m plus 2 raised to the third power, what we're going to do is we're going to list the terms vertically. We start with, we're raising it to the third power, so we're going to the row in Pascal's triangle in which the second value is 3. The second number is 3. So I'm going to this row in Pascal's triangle, right? And we're going to write down 1, 3, 3, 1 vertically. 1, 3, 3, 1. Next, we're going to multiply by the first term in our binomial, which is m. And the exponent is going to start high, whatever our n value is, in this case 3. And then we're going to decrease in each subsequent line. 2, 1, 0. Then times, we take our second term of a binomial 2, positive 2, and its exponent will start at 0 and increase. So 2 to the 0, 2 to the first, 2 to the second, 2 to the third. Now we'll multiply across. 1 times m to the third times 2 to the 0. That's 1 times m to the third times 1, which is m to the third. 3 times m squared times 2 to the first is 2. 3 times 2 is 6, so that's 6m squared. 3 times m to the first is m, times 2 squared is 4. 3 times 4 is 12, 12m. 1 times m to the 0 is 1. 2 to the third is 8. 1 times 1 times 1, or sorry, 1 times 1 times 8 is 8. So here are our 4 terms that result. So let's list them. Write them as the polynomial m to the third plus 6m squared plus 12m plus 8. So m plus 2 raised to the third power expands to this 4-term polynomial. All right, so once again, whatever power it's being raised to, that's the line you take from Pascal's triangle. It's being raised to the third power, so I'm looking at the line in Pascal's triangle where the second digit is a 3. Copy that down. 1, 3, 3, 1. And then we take the first term of our binomial, write that down after it, and then the power starts at n and decreases by 1 each time. And then take the second term of our binomial, write that down, and then the power for that starts at 0 and increases by 1. Let's look at the next one. we want to expand a minus 3 raised to the 4th power. Okay, well, I'm raising to the 4th power. So I need Pascal's triangle. I start with a triangle in the form of 3 ones. All right, because this is Pascal's triangle is not given to you. Write down each one, and then add 1 and 1 is 2. Bring down the ones towards the outside, add 1 and 2 is 3, 2 and 1 is 3. Again, bring down the ones towards the outside, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4. Okay, so this is the line I want right here. All right, 1, 4, 6, 4, 1. Now, our first term is A, so times A. Now, so I'll just write A down, and now I'll worry about the power. It starts high at 4 and then decreases by 1 each time. 4, 3, 2, 1, 0. My multiplication symbols again. Maybe I'll use parentheses next time. So now I have negative 3, right? This term is negative 3. Pick up the negative. Yeah, it's better using parentheses. And the power on our second term starts at 0 and then increases. 2, 3, 4. Okay, so now we compute each. This is 1 times a to the 4th times negative 3 to the 0 is 1. That's a to the 4th. This is 4 times a to the 3rd times negative 3. This is multiplication. Negative 3 times 4 is negative 12. A to the 3rd. This is 6 times a squared times negative 3 squared is positive 9. 6 times 9 is 54. A squared. This is 4 times a to the 1st is a, times negative 3 to the 3rd is negative 27. Negative 27 times 4 is negative 108. A. And 1 times a to the 0 is 1, times negative 3 to the 4th is a positive 81. And there we have our terms, all 5 of them, as we should, because it was being raised to the 4th power, so there should be n plus 1 or 4 plus 1, 5 terms. And now let's just list them in order. A to the 4th minus 12a to the 3rd plus 54a squared minus 108a plus 81. And our next example, we want to expand 2x plus 3y raised to the 5th. Okay, so this is being raised to the 5th. So let me go up to my Pascal's triangle here, and let's draw out one more line. Bring down the ones towards the outside. Add 1 and 4 is 5. 6 and 4 is 10. 10, 5, 1. Okay, so I'm raising to the 5th. So I write vertically this line, 1, 5, 10, 10, 5, 1. Okay, now our first term is this 2x. So this is going to be 2x, 2x, 2x. Exponent starts high, 5, and decreases, 4, 3, 2, 1, 0. All right, next term is 3y. So I write 3y. And the exponent starts 0 and increases, 1, 2, 3, 4, 5. All right, ready for some powers here. All right, so this is 1 times 2x to the 5th. this is, make sure you distribute over this product, right? That'd be 2 to the 5th, which is 32, x to the 5th. 3y to the 0, anything to the 0 is 1. Let's see if I can try to get rid of this shadow here. Oops, I thought I stopped it. I guess I didn't. Sorry, I just got up to so that the lights would turn back on. All right, so this is 32 x to the 5th. Next, 5 times 2x to the 4th. Make sure again you distribute 2 to the 4th is 16 x to the 4th times 3y to the 1st is 3y. 5 times 16 is 80 times 3 is 240. So 240 x to the 4th y. Next we have 10 times 2x to the 3rd. 2 to the 3rd is 8. X to the 3rd times 3y squared. 3 squared is 9. Y squared. Well, that's good. So that's 72 times 10. That's 720. X to the 3rd y squared. Trying to speed up a little. 10 times 4x squared times 3 to the 3rd is 27. Y to the 3rd, which is going to be 108, so 1080, 1080, x squared y to the 3rd. Next, 5 times 2x times 3y to the 4th. 3 to the 4th is 81, y to the 4th. So 81 times 10, that's 810, x, y to the 4th. And lastly, 1 times 2x to the 0 is 1. 1 times 1 times 3y to the 5th. 3 to the 5th is 243, y to the 5th. So 243, y to the 5th. So here we want to list now all 6 of our terms with addition signs between them. So 32, x to the 5th, plus 240, x to the 4th, y, plus 720, x to the 3rd, y squared, plus 1080, x squared, y to the 3rd, running out of room here, plus 810, xy, plus 243, y to the 5th. That xy should be an xy to the 4th. Double check my exponents. X's go 5, 4, 3, 2, 1, 0, and y's 0, 1, 2, 3, 4, 5. Okay, so that's our answer. Now, sometimes you are asked for only one term of a binomial expansion. You can expand the entire expression and select a particular term. So in this case, we want to find the third term of the expansion, 3x plus 2 raised to the 5th power. All right, so we want to raise this to the 5th. So I'll look up at Pascal's triangle, all right, and copy down this line, 1, 5, 10, 10, 5, 1. But we want to find the third term, all right? So this is the first, second, third. So this is the only one we really need to calculate, all right? But we'll start with our first term is 3x of our binomial is 3x. So I write 3x, 3x, all the way down. But I know I'm only going to go to the third term, so I can actually stop there. And then the second term of our binomial is 2. 2. Oh, and I forgot my powers. So our first term, the 3x, the exponent starts at 5 and decreases 5, 4, 3, 2, 1, 0. And then for 2, it starts at 0 and increases 0, 1, 2. All right, so again, we only need to compute this right here. So this is 10 times 3x to the 3rd. Well, 3 to the 3rd is 27. X to the 3rd times 2 squared, which is 4. 4 times 27 is that 108 times 10 is going to be 1080 x to the third. If you feel comfortable, try the next one. Pause the video and try the next one. Right here we have 2m minus 5 raised to the 6th power. So I need another line of Pascal's triangle. All right, it's way up top there. I think just for practice, I'll write it over, calculating it for each line. 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and then 1, 6, 15, 20, 15, 6, 1. So I'm writing down these 7. 1, 6, 15, 20, 15, 6, 1. And I want the middle term, so that would have to be right here in the middle of these 7, the 4th term. 2m this exponent starting at 6, then 5, then 4, then 3. And our negative 5 starts at 0, 1, 2, 3. And now let's work this through. This is going to be 20 times 2m to the third, that's 8m to the third. Negative 5 to the third is negative 125. Remember, this is multiplication, that's a negative. Okay, we're multiplying. This results in negative 20,000 m to the third. Yeah. Okay, and that concludes our video. Thank you.